So hello everyone, in this video we are going to talk about some accuracy measures in classification of a general classification problem, not only logistic regression. So we will actually see that whether measuring the raw accuracy in these classification problems will be beneficial, or there would be some other techniques. What would be the drawbacks of measuring raw accuracy, and like how are we actually going to say uh, that our classification models is performing well or not. So by the end of this video you will be able to understand pure accuracy and issues related to it, learn about some confusion matrix, learn about something called precision and recall values, and also these F1 scores. These are actually the real accuracy measures, and the pure accuracy simply calculating the percentage won't do. So we'll see that how. So in logistic regression, adding more features to the model will always increase the training accuracy, that is low bias, but the testing accuracy increases only if the added features are found to be significant. So this is a major thing which you need to keep in mind. So for the classification model's performance, the percentage accuracy is not the best way for the classification model. So let us see why it is not the best way. For example, in our data set we have 95 zeros and 5 ones. Then we have 95% accuracy even if we start predicting 0 for every case. So did you understand this thing? By chance, by coincidence, if in our database we have 95 zeros and 5 ones for in our training database, then even if our model is that bad that it always predicts 0, even if our model is that much bad, then also we are having 95% accuracy. So even after creating a very disastrous model, we are getting 95% accuracy. So definitely percentage score is not a correct measure for a classification problem, because in our testing data set we may have 100 features in which all are ones, and there we will get 0% accuracy because our model always predicts 0. So you understood this concept, I guess. So now there is something called confusion matrix. So let us say we have a total 50 class of 0, out of which we predict 40 correctly. We have 0, 0, 0, 50 in our training data, out of which we are predicting 40 correctly. Our algorithm is predicting correctly 40 of them. And let's say we have 50 class 1 values, out of which we predict 45 correctly. Then our confusion matrix will be something like this. So what will be the dimension of a confusion matrix? So it will be number of classes. If the number of classes is n, then the dimension of the confusion matrix will be n cross n. So if you see here, these are the predicted 0 values. So how many values we predict 0? Our true value of 0 is 50, 40 plus 10. Out of those true zeros, we predict 40 of them correctly and 10 of them incorrectly, that is we predict 1 for them. If we predict 40 correctly, we predict 10 incorrectly. And similarly, our true value is also 50, 5 plus 45, and we predict 45 of them correctly. We predict 1 in 45 cases, and we predict 0 even in true 1 in 5 of the cases, 5 of the remaining cases. So in this way we construct something known as confusion matrix, and then we try to derive some formulas from this confusion matrix. So the two things which we will derive is known as precision and recall values. So let's say we have a confusion matrix which looks something like this: predicted a value and b value and true value of a and b. So you can say that a is 40 plus 10, 50, and b is also 50 cases, out of which we are doing some misclassification also, 8 and 10. So what is our precision of a? Precision of a would be 40 upon 48. It means that how much precise we are in predicting a. We predicted 48 out of, we predicted class A as 48 of them, but actually 40 are correct. So our precise value is 48, 40 out of 48. What is our precision of B? So actually we predict 52B, we are predicting 52B, 42 plus 10, out of which 42 are correct. So 42 out of 52 is the precision of B. And what would be the recall of A? So true value of A is 50, out of which we recall 40 of them correctly. So it will be 40 upon 50. So this recall value of A will be 40 upon 50. Similarly, recall value of B, we have 50 of the true values of B, out of which we could recall only 42 correctly in our predicted column. So we get 42 out of 50. So these are some of the terms which we need to know, and then we calculate something known as F1 score. So F1 score is the harmonic mean of the precision and recall values, and is a for and is a far better, like it is a far better performance measure than simple percentage accuracy. Now let us return back to our data set and let's understand what is happening. So you know what is a harmonic mean. So 1 by h equals to n by 1 by precision plus 1 by recall. So the F1 score is basically, you can calculate it to be 2ab by a plus b. You can get it like that, where a and b are recall values and precision values. So for example, in our data set we have 95 zeros and 5 ones, then we have 95% accuracy even if we start predicting 0 for every case. I told you in the beginning of this video about this problem. But what about the F1 score? Confusion matrix would look something like this. That is, we are always predicting 0. In all the cases we are predicting 0 and we are never predicting 1. So our confusion matrix would look something like this, and the recall value of 1 would be basically 0, because there are 5 true values of 1, out of which we recall only 0 correctly. So recall value of 1 will be 0, and hence the F1 score would be 0, because F1 score is nothing but a harmonic mean of the precision and recall values. So harmonic mean, I told you it to be 2ab by a plus b, where a and b are recall values. So if you put a equals to 0, F1 score will be 0. So let us just understand how to apply this logistic regression in our sklearn. So from sklearn we import data sets. In the linear model we import logistic regression just like linear regression, and from the model selection we are importing train test split. So in the iris dataset, we are just doing the load iris function, and we are just doing the train test split. This we have been doing again and again in every video almost. So you should be quite familiar with this. This random state signifies no matter how many times I run the code, I will always get the same value of the y train and x train. So CLF, we create an object, logistic regression, with solver equals to lib linear. Now fit, we are doing fit on our training values, and then we are predicting from the training values once, and we are predicting from the testing values once, and then the confusion matrix on our training data set will look something like this. So from the above confusion matrix formed from the training data, we notice the following things. So class 0 has 37 data points and all of them are labeled correctly. Class 0, class 1, class 2. Class 1 has 34 data points out. So basically each row signifies each class. So class 0 is this row, class 1 is this row, class 2 is this row. Of the true values, I told you this, the row signifies the true values. So class 1 has 34 data points, out of which 28 were predicted correctly. So here it will be the true class 1, and here it will be the, in the row it will be the true class 1, and column will be the predicted class 1. Similarly, in this row will be the true class 2, and this column will be the predicted class 2. So class 2 also had 42 data points, all of them which are labeled correctly. So this inference we can draw from these class. And there is also something known as classification report, which basically gives us a complete report of our precision value of 0, 1, 2, recall value of 0, 1, 2, what would be the F1 score, what would be the accuracy, and this is the weighted average and macro average, which you can easily find out. What are they? So weighted average will be the weighted mean actually. And from the sklearn.matrices we import this classification report. So one thing you must notice, in our upcoming videos we are going to learn more classification methods, not only logistic regression, some more methods we will learn. In those all those methods we can import this classification report. We can calculate F1 score, we can calculate the basically confusion matrix in all the classification problems. So yeah, that's all from this video. In the next video I will try to do some projects on this. So till then, thanks a lot.